Hello everyone, welcome to Keep Learning at the Rate Be Creative. In this video, we are going to see the solution of practice problem number 8. If you have not tried it till yet, pause the video and try to solve it first. It's a very interesting problem and we are going to learn some concept related to circle and quadrilateral in this problem. So let's begin with the solution. Here we have been given AB is the diameter of the circle. So this length AB is the diameter of the circle. We have been given the radius as 5 unit. CD is the parallel to AB. CD is the chord parallel to the chord AB or diameter AB. So CD is this chord which is parallel to the diameter AB. AEF. So AEF, this is the tangent to the circle, and you can see that AB is the diameter. So we can say that from center A is from this point, center point till A is this the radius which is connecting to the tangent at the point of contact. So we can use this property also, that radius is perpendicular to the tangent at the point of contact. So if we will be needing, we are going to use this property as well. Now the last point, that is we need to find the value of AE into AF. So we need to find the value of AE, this length AE into this length AF. So let's begin with the solution here. Since we have been given that chord CD is parallel to AB, so I can mark this as parallel lines or parallel line segments. Now I will connect A to C so as to get a quadrilateral, so it will become easy for me to choose the angles. Now since we have AB parallel to CD, this AB was parallel to CD, so I can say that ABDC is a trapezium, and it's not only a trapezium, it is a cyclic trapezium, so it will be isosceles. So ABCD is an isosceles trapezium. So you must be knowing, if we have a trapezium which is cyclic, then it will be a isosceles trapezium. Now, what is the property of an isosceles trapezium? So for an isosceles trapezium, what we have, the base angles equal. What in the isosceles trapezium is where the non-parallel sides are equal. So we have this base angles also equal. These two and these two are also equal to each other. So since I will be needing the angles, so I'm going to mark these two base angles equal here. So here I will have angle CAB. Let me mark this as angle theta. So angle DBA, this angle will also be theta. So these two angles will be theta. Further, we have some 90-degree angles. Let us mark them. So here you can see that since AB is the diameter, so angle ACB will be angle in the semicircle. This angles come out to be 90 degree. This angle will be 90 degree. Also, since AEF was tangent and AB is the diameter and A is the point of contact, so here again we will have this angle as also 90 degrees. So we have two right angle triangles here which we have marked. Basically we have more right angle triangles, so we will use the right angle triangle, whichever right angle triangle we will be requiring. Now let us chase some more angles. Now here, since I have marked this angle ABF as theta and angle FAB is 90 degree, so here you can see that angle, this angle is theta and this angle is 90 degree. So in triangle FAB, in this triangle we have two angles, one is 90 degree, another is angle theta. Also I can mark the remaining angle as 90 minus theta. So this angle comes out to be 90 degree minus theta. Now why I have considered this triangle, because we have this length AF in this triangle, this bigger triangle. Now I need EA also, so I will have two triangles which is related to this AE length. That is, one is ECA and the other one is EAB. But I will like to consider the triangle EAB. Why? Because in that I have AB as the diameter whose length is known to me. Also, the initial triangle which I have mentioned, that is FAB, in that also I needed AF, also I had AB. So now I have two triangles in which one length is required and the other one more length is given in that triangle. So what I basically want to say, let's see. So I have already marked the two angles in the bigger triangle. Now this angle comes out to be, then in that case, this angle comes out to be as 90 minus theta. 90 degree minus theta. And if this is 90 minus theta and this angle is 90 degrees, so this angle comes out to be theta. This angle comes out to be theta. So now I have two triangles in which I have the values as theta and 90 minus theta. So I can very easily write triangle FAB similar to triangle FAB. So I can write triangle name as here I would have this angle as 90 minus theta. This angle will be 90 degree minus theta. So since F is 90 minus theta, so this angle will be B here. Since in triangle EAB I have angle B as 90 minus theta, then A is 90, so I'm going to write again A angle here, and this will be E. So these two triangles are similar by angle similarity. Now since these two triangles are similar, what I needed is AF and I need AE. So let me write down the ratios of the sides. So I can write FA, and corresponding to that I have here that is BA, that will be equals to, here I need AE, that is from last two letters, so also I have to take AB, the last two letters of the first triangle, that is AB upon AE. Now on cross multiplying I'm going to get AF into AE, that will be equals to AB square. Now I have already mentioned that AB is the diameter. We already know the length of the radius, that was 5. So this complete length, that is the diameter, that will be equals to 10. Let's substitute the value. So this will be 10 square, that is equals to 100. So what we needed was AF into AE, that comes out to be 100. So this is the final answer to this question. And let's see the options are also being given to us. So in this we will have option 3, that will be the correct answer. I hope you must have liked the video. For more such interesting problems and concepts related to geometry, please like and subscribe our channel. Thanks for watching.